In this lesson, we will solve two-step inequalities. When solving two-step inequalities, we use a similar process as when we solve two-step equations with one small difference. We move the variable to one side. We use inverse operations to solve for the value of the variable, which is your unknown. The difference here is that when you are dividing or multiplying by a negative, you have to flip the inequality sign. You are still using the opposite of PEMDAS, which is your order of operations. Here is a chart with your inequality symbols. When we graph your solution for an inequality, if you have a less than or greater than sign, you will use an open circle. And when you have a less than or equal to and greater than or equal to, we will use a closed circle. And remember that you can differentiate between the less than and the greater than because the less than looks like an L, kind of like an angled L. So let's take a look at some examples. Number 1, we have 5 times p plus 3 is less than or equal to 28. So we're following the same steps. First, we have to undo the addition here. So we undo the addition by subtracting 3 from both sides. So here we are left with 5p is less than or equal to 28 minus 3, which is 25. Next, we have to undo the multiplication. So we have to divide by 5 on both sides. So we have p is less than or equal to 25 divided by 5, which is 5. Notice here we're not dividing by a negative, we're dividing by a positive 5, so our symbol stays the same. Now in graphing, remember that your less than or equal to is shaded. But let's go ahead and write this out as a verbal statement. So we have p is less than or equal to 5. Now we can actually check our solution just like we have checking equations. So if I select a number that is less than 5 or equal to 5, it should make my inequality true. So let's test it out. If I select a number less than 5, let's just say 3, let me go ahead and plug that in. I have 5 times 3 plus 3 is less than or equal to 28. So it's different than an equation as well, because here you have an infinite amount of solutions. 5 and everything less than 5 is a possible solution for your inequality. So 5 times 3 is 15. 15 plus 3 is less than or equal to 28. 15 plus 3 is 18. 18 is less than or equal to 28. So any number you choose that is either 5 or less than 5 will make that inequality true, okay? So let's go ahead and graph it on a number line. We are selecting all the numbers that are less than 5, which would be all the numbers to the left of 5. So that would eliminate letters A and B. And now when we have the equal sign, that makes 5 a part of our solution. So that would be a shaded circle. So that would be letter C. Let's take a look at number 2. We have negative 2 plus 10 times t is less than 88. So here we have to get rid of that subtraction or that negative. So we add 2 to both sides. And we are left with 10t is less than 88 plus 2, which is 90. Next, we have to undo our multiplication. So we have to divide by 10 on both sides. So here we are left with t is less than 90 divided by 10, which is 9. Now here, once again, notice that we're dividing by a positive 10, so our symbol stays the same. So we have t is less than 9. So if I plug in any number less than 9, it should make my inequality true. So let's go ahead and test that out. We have negative 2 plus 10 times let's just say 5. 5 is less than 9, and that should be less than 88. So we have negative 2 plus 50 is less than 88. Okay, here we're adding integers. Okay, we have different signs. Okay, so we subtract, so that would be 48, and it would be a positive 48. So 48 is less than 88, which is true. Okay, so any number less than 9, if I plug it in, that will make my inequality true. So let's go ahead and graph it on the number line. We are selecting all the numbers less than 9, so 8, 7, 6, 5, 4, and so on. So we're graphing towards the left, so A and C are not our answer. And we do not include 9 in our inequality, in our solution, so that would be letter D. We have an open circle here. Okay, moving on to our next example. We have number 3, negative 3x minus 5 is greater than negative 35. So let's go ahead and undo the addition first. The subtraction. So we have to add 5 to both sides. And we are left with negative 3x is greater than negative 35 plus 5. Here we have different signs, so we have to subtract. So 35 minus 5 is 30, and we keep the sign of the larger number, so here the negative is larger, so it's a negative 30. Divide both sides by negative 3. So we're left with x is greater than, not greater than, it changes, remember it flips because we are dividing by a negative. So we're left with x is less than negative 30 divided by negative 3, which is positive 10. So our solution is x is less than 10. So any number less than 10 is a part of our solution. So let's go ahead and plug in a number less than 10. We have negative 3 times, let's go ahead and plug in 6. 6 is less than 10. Minus 5 is greater than negative 35. So rewrite your original. We have negative 3 times 6 is negative 18. Negative 18 minus 5 is greater than negative 35. Negative 18 minus 5, those are same signs, so we add them up, which is negative 23, is greater than negative 35, which is true. Okay, so any number that we plug in that is less than 10 will make that inequality true. So let's go ahead and graph it. We have x is less than 10, so anything less than, which is towards the left of 10, so A and B are incorrect, and we have an open circle because 10 is not part of our solution. So our answer here is letter C. Moving on to number 4, we have 19 is greater than or equal to 5 times g minus 1. Okay, so here we have our variable on the right side, so let's go to the right. Here we have subtraction, so let's get rid of it. So let's undo subtraction with addition. Add 1 to both sides. So here on the left, we're left with 19 plus 1, which is 20. 20 is greater than or equal to 5 times g. Now we have to undo the multiplication. So divide on both sides by 5, positive 5. So here we're left with 20 divided by 5, that's 4. So 4 is greater than or equal to 5g divided by 5, which is just g. All right, so we can leave it that way, but just so that I can read the variable first, this is correct, but sometimes it gets a little confusing to read it this way. You can, but I'm going to show you the second way to write it. So we can write it like that, or we can write it as g is less than or equal to 4. We're basically just flipping everything. So g is less than or equal to 4. So if we select any number that is less than or equal to 4, our inequality should be true. So 19 is greater than or equal to 5 times, let's say 2, minus 1. So we have 19 is greater than or equal to 5 times 2, which is 10, minus 1. 19 is greater than or equal to 9. 19 is greater than 9. So our solution is true. And that works for any number that I select that is either 4 or any number less than 4. So let's go ahead and graph it. We have that equal sign, so I'm going to have a closed circle. And we want all the numbers less than 4, so we're graphing towards the left of 4. So we're either between A and B. We have the dogs in the background barking. And we are shading our circle because 4 is part of our solution. Here are some problems for you to try out on your own. Remember that when we divide by a negative, you flip. Let's go ahead and summarize. Remember that solving two-step inequalities is pretty much the same as solving two-step equations. The only difference there is when you divide by or multiply times a negative, okay? So you move the variable to one side. You use inverse operations to solve for the variable. And then finally, when we divide by a negative or multiply times a negative, we have to flip that inequality sign. And remember, when we use inverse operations, what we're doing is we are basically just going through PEMDAS, but just the opposite of it. So we're going through order of operations backwards. That's it for this lesson. I hope this lesson has been helpful. And if you have any questions, don't forget to reach out. Thanks for watching, and I'll see you in the next video.